Well, good morning, everyone. Welcome back to the second session. Our second speaker of this morning is a self-employed building design and environmental consultant and is currently working on setting up West Berkshire's Draughtbusters with a speech titled Draughtbusters, Stop Energy Waste. Please welcome Neal to the stage.
Good morning. Thank you for the welcome. I'll press the wrong button. Right, we're setting up Draughtbusters West Berkshire, which is it's an initiative started off by West Berkshire Council. We'll be a charity. We're using. Oh, sorry. Yep. And we're using a template from a national initiative of Draughtbusters. The aim is to provide free draft proofing service to those who need it, unwaged, people in distress, elderly. We're also providing people like yourselves with the information to carry out work themselves. Draft proofing is an eminently DIY possibility. It's all simple technology. So we're hoping with talks like this to encourage people to do it for themselves. Reading Draughtbusters have been going for a couple of years. They've done 250 homes. Cheapest cost £1.50. The most expensive is about 15, maybe £20. These savings are before the current cost increases. So you can spend £1.50 and save £120 before the cost increase. So double that or whatever it is now. You're looking at substantial savings. The biggest saving they made was £600 per annum just for a front door, and I'll show you a picture of that later. Not a single loft trap during their first year of working was insulated. People insulate their lofts and they've got this little wooden hole which they leave completely uninsulated and completely draft free. So we'll talk about that in a minute. One client could have saved over £1,000 over 5 years if she'd just blocked up a redundant air brick, which was put there to provide air for a fire, which are no longer used. Draft proofing helps in two ways. It stops heat from your house disappearing outside, but it also makes your house more comfortable. And because your house is more comfortable, you can drop circulation temperature. And this thermal comfort is very important. If air is a good insulator, if it's not moving. So if you've got a still house, the air around your body heats up to your body temperature and you feel comfortable. If you've got a drafty house, the air's moving away, it takes the air from your body, so you've got cold air around your body and you feel cool. So if you draft-proof your house, you can drop that thermostat temperature by 1 or 2 degrees and you'll save considerable amount of money just with a lower temperature in your house. So it reduces your costs. Full draft proofing, save about £90 a year at old energy costs. Draft proofing is more comfortable. Turn down your thermostat and that could save you another £60 a year by turning your thermostat down 1, a bit more if you turn it down 2 degrees. The biggest way of saving yourself money is by putting on a jumper. Wear winter weight clothes even in your home. I work outside a lot. I've got a small holding. I dress for outside, and then when I come in and sit down, I just undo a few buttons. So I've got 3 layers outside. I've got to wear 3 layers inside, but just undo some buttons to vent it a bit. It's a bit extreme, but it saves me a heck of a lot of chopping of logs. So I'm quite happy doing it. It's something that we've forgotten about with all the joys of central heating, but dress for winter. Drafts are caused by gaps between various building components. So you'll get drafts around your windows where you get movement around the frame, between the frame and the brickwork. You'll get them at floor ceiling joints. On most cavity walled houses, the joist, the ceiling joist goes into the wall, and there's a gap around the ceiling joists between the brickwork and the wood to stop the wood getting damp, and then that communicates with the cavity, and the cavity communicates outside. So if you can seal that joint and then cavity fill your house, you'll save drafts, and you'll also save yourself money by insulating the cavity. So if you're looking to find drafts in your house, look at all the joints. Any change of direction on a wall surface, and there's a possibility of a draft at that position. And then you've got the obvious things like your post box on the door, letterboxes, keyholes. If you've got the old 5-lever keyholes with a keyhole right through the door, that's going to let heat out. It's amazing the amount of a draft you can get through that. So if you don't use the keyhole on the other side, just put a bit of sticky tape over it for the winter, and that'll save you a few quid. Loft hatches, they are notorious for losing heat. As said earlier on that people will spend a fortune insulating their loft and then forget the loft hatch. So either put some fibrous loft insulation material in a bag and just put it over the loft hatch when you shut it, or buy some of the foam boards and fix that to the loft hatch. But then draft proof the lip where the loft hatch sits in, or if you've got one that flaps down, draft proof the lip underneath, so when you push up, the latch holds the hatch against the insulation. If you've got one that drops down, windy day can lift that loft hatch and suck your air out. So put a couple of latches on it so that it holds it down against the draft proofing. The other thing is there's a joint between the loft hatch frame and the main structure, so you've got to make sure that is sealed as well, because it's at the top of your house, hot air rises, and if you've got gaps there, it'll go through. If you've got pipes in your airing cupboard that go through into the loft, make sure the holes there are sealed, because again, you've got a hot space and heat rises, so make sure it's not rising into your loft and disappearing. Downlighters are a pet hate of mine. I think they should be banned. They're notorious for losing heat. They should come with a cap, but that cap's very rarely fitted. If you look at the construction of a downlighter, it's a hole basically in your roof. So fit the cap on it. If you can't get a cap, a ceramic flower pot popped over the top will do. Anything that's fireproof, stick it over the top, or heat proof, stick it over the top, and then insulate. Another thing to do is get rid of the old halogen downlighter bulb and put an LED bulb in there. That'll save you energy, and the heat won't be such a problem. So look at downlighters. A friend of mine bought a newer, smaller house than his old one, and couldn't keep it warm because he had about 40 downlighters spread around the house, and each one of those, they'd taken the insulation off, and he had sloping ceilings where the roof goes up. And so he was lying in bed at night. On a frosty night, he'd wake up in the morning with frost around his mouth because the heat was going out the downlighter over the bed, straight into the loft and straight out into the atmosphere. It was costing him absolute fortune. So downlighters are something should be banned. Anyone who suggests using downlighters, shoot them. Suspended floorboards. They are another source where you have air bricks which provide essential ventilation under the floorboards. You can't block those air bricks up because you'll get damp problems with your house. So you need to look at the floorboards. The ideal thing to do is take the floorboard up, insulate between and under the joists if you can. You're looking at 4 to 8 inches of insulation under that floor is worthwhile putting in if you can. Before you put the floorboards back down, you need to put a vapour-proof membrane over the floor to stop insulation getting into it. So typically use polythene, something like that, and seal that around the edges of the floor, and then put your floorboards back down on it. If you can't do that, we will show you in a little while what you can do to stop drafts coming up, because that is a big source of drafts in older houses. Pipe work leading to the outside, pipe boxes which go from your kitchen or bathroom up into the loft. They're another source of air leakage. Ceiling to wall joints. I said before that you get air going into your ceiling void and then out the house. And redundant air bricks. They are a huge source of drafts. It used to be a public health requirement that every room had a 9x9 air brick in it. They've thankfully been blocked up now and aren't put into houses, but there are plenty of houses with those. Also where you've had an open fire in a room or a gas fire, they're a mandatory requirement. So you need to be able to control the draft in the house. So if you can arrange underfloor draft for the fire, and then have a cut-off so you can turn it off when the fire's not going, it's another useful thing. Gaps and cracks. We're looking at a door or a window. This is a plastic window that you can get drafts through. The building regulations require that doors and windows are sealed to the structure on the inside and the outside, and that's not always done. Also, mastic that can wear or age and crack, so you need to check that those seals are still working. So it's the cracks around the frame as well as the draft excluding around the window, which you need to look at. Where you've had a new pipe put in for a bathroom or a shower, there's often a hole there, so you need to look at those, block them up inside and out, because if you will get, even with a cavity filled cavity, you can get air movement through, especially where someone's made a hole to put a pipe through. So look at places like that. Even where you've got a seal around, a cement seal around a pipe like that, it's worth looking at it on the inside, because again, that cement won't completely seal that. So you need to be looking at what's happening inside as well. Here we go. Floorboards. That is a huge source of air loss, even at first floor level, because of the conduit under the floor into the cavity and out. A first floor bathroom or bedroom with nice stained floorboards really needs sealing. Loft hatches we've talked about, so it's this sort of joint around the edge of the frame as much as the joint between the loft hatch and the frame, and don't forget to insulate that board. Chimneys, they cause a huge air loss if they're not sealed. If you're not using that chimney, take it out and have a bit more space in your room. If you can't afford that, you really need to cap the chimney. Chimneys need to be kept vented, because if they're not vented, that they will you can get build up of moisture in there, and because of the tars and things in the chimney, that can leach through and cause problems with your decoration. So when a chimney is blocked off, there should be an air brick at the top, so that's still leaving a draft path or an air loss path up the chimney. So it's best to block the chimney at the bottom. If you block it at the bottom, you stop the heat going into the chimney, but the air in the chimney will warm up slightly, and that will be enough to carry any moisture out through the brick, through the air brick or the vent that you've left at the top of the chimney. So that will keep the chimney dry without causing a huge loss in the room. We will be either fitting a cushion. You can get on our stand. We've got a blow-up cushion that you can put up there, or if you put a normal cushion into a black plastic bag, you can shove that up there as well. That will stop it. If you're looking telltale signs of drafts on a window, if you get cold air coming in, you'll get a bit of dampness on the frame. That'll collect dust, so it points, literally gives you an arrow to where you've got a leak. So you look at that sort of thing around the house, and you can find where you've got leaks that way. The gap between the window board and the frame is one situation, but then on the inside, underneath the window board, between the window board and the wall, you'll also have a leak or possibility for leaks. Missing or detached. I've got one to fix myself on a French door. The draft sealing comes loose after a while, so you need to either stick that back in place or buy a new seal and fit it in. Make sure it's tucked well into the groove, so that it all locates and seals the drafts. There's a draft stripping method for virtually every situation, ranging from these brushes which fit on the bottom doors on the inside, the P-type rubber seals, V-shaped seals, so the wind pressure coming in acts against that V and pushes it against the window, so it increases. The stronger the wind, the better the seal you'll get. There's horses for courses. You can buy various size circular rubber strips, and they are ideal for putting between those floor joists. The floorboards. You get a little wheel to push it in, which we've got on our stand, or you can use the back of a knife or something. Something that's particular for older houses around here, where you've got a timber frame house, an old oak frame house with a, what's happening? Put it down. You've got a timber frame house with brick infill in the panels. I've got this on a timer on my laptop, and he said they'd taken the timing settings off, but I don't think it is. Anyway, yeah, brick infill panels in a timber frame house. That rubber sealant you can put round the brickwork to seal it. It comes in 3 or 4 different diameters, so you can get a diameter which suits the seal. So push that in and then go around it with a mastic just to hold it in place, give it some protection. Letterboxes, these things you can buy for about a £5. The local shop who have a stall outside, they sell them. So there are various types, brush type seals or flap seals. So the best one is a sprung flap with a brush as well, so it's belt and braces. So £600 worth of air a year, of hot air a year, vanished under that door. This is an older house with a worn concrete sill. What they did there, they cut a strip of wood to suit, screwed that down with a mastic seal, and then put a door seal against it, and that saved that woman £600 a year. So it's things like that, especially with older houses that need sorting out. You can see it's got a door seal around it, but it hadn't done anything under the door. So it's pretty obvious to most people, but not to some. What's under your sink? It all gets sealed in and forgotten about, but when the guy put the new pipe in, he cut a bit of floorboard out and left a large hole there. So look under your worktops, take the kick flap off and have a look. It's well worth it, because you get horrendous things. Just general energy saving advice: keep your doors and windows shut. Put door springs on to make sure that they're shut. If your kids run in and out all day and don't shut the door, put a spring on it just to make sure it closes. Draft proof. It's the cheapest, most cost-effective thing you can do. So look at your draft proofing. Insulate your walls. I've done 3 designs on 70s and 80s houses to save 80% of my fuel bills. One guy spent 30 grand on it, used his pension lump sum, and he gets 7% rate of return before the energy prices went up. He's better off insulating his house to a very high level than he is buying an annuity with his pension lump sum. Gets better rate of return on it. So the government's Green Deal was a really good idea. The thing that killed it was 6-7% interest rate. So if you've got the money, it's well worth spending it insulating your house. He put equivalent 450 millimetres of fibrous insulation in his loft. Put 5 inches, 125 mil of external insulation right around the house. Triple glazed, mechanical ventilation with heat recovery, and what else did he do? And just general sealing of the structure. So the loft insulation joined up with the wall insulation joined up with the windows and the doors, and he insulated around the outside of the house. He couldn't get to the floors because they're concrete, so we insulated around the outside of the house, and that joined up with the wall insulation. That gave him a 7% return on his capital, and an extremely comfortable house. Because he'd insulated so well, he could turn the thermostat down. He runs his house at sort of 20, 21 degrees, and he's perfectly comfortable at that. Fit programmable room stats. But above all, you've got to ventilate. If you draft-proof your house so it's absolutely airtight, you can then control your ventilation. If you've got gaps in it, you can't control the ventilation rate. So you're going to be losing money. So do the draft proofing, but either have trickle ventilation somewhere or purge ventilate. So open your doors and windows for half an hour a day. Air will carry heat out, but air doesn't actually contain a lot of heat. So your structure will be warm. So open the windows, let the air out the house for 15 minutes, half an hour, every 2 or 3 days, and the structure, the warm structure of the house will very soon warm that air up again. So it seems sort of counterintuitive to draft proof and then open your windows, but it's essential for health and of you and your building structure. If you get a build-up of moisture in the house, it'll find somewhere to condense. It'll be on the windows, so it'll start damaging your windows frame and surround, or it'll go into the walls, and you eventually get mold growth. And we've all seen the horror pictures of mouldy homes, and you can get a mouldy home even with a well-insulated home. So it's not just about cold homes. You've got to keep your ventilation rate going. So that is essential. You know, we're selling you sealing the house, but you've got to open those doors and windows. So, any questions? Yes, please.
I insulated my loft several years ago, and I moved into the current house, which is a very modern house. Having done that, I now get condensation in the roof space.
Yeah.
I don't know if this is a common problem or not. I expect the solution is more ventilation up there.
Yeah.
But I'm just sort of curious as to whether you've encountered this and whether anybody else has.
Yeah, so I'll just repeat the question for the camera. The gentleman's insulated his loft space and he's getting condensation in the loft. What can you do about it? If the condensation, go back. The regulations require ventilation into the roof space. There should be a ventilation gap between the insulation and the roof space. Should be 2-inch gap. Most builders just ram it full. So your answer is you either tuck the insulation down so you've got 2 inches gap all round, so that'll allow wind to get in over the insulation and clear the condensation. If you can't do that, fit some vent tiles around the roof, above the level of the insulation, so you get that air movement over the top of your insulation.
With roofs again, when you have a sort of a 30s house with skeelings,
Yes.
and you want to tuck ventilation down into the skeeling bit,
Yes.
you then lose that.
That insulation. Yeah.
Yeah. So what do you, is that where you need to put a ventilation tile higher up above the insulation again?
Depends on the length of the ski. If it's a very long skeeling, you need to keep it ventilated. If it's a short one, you often get them a foot or 80 inches. You could probably afford to block that completely and then put vent tiles above it. The other thing you can do is either fit a board insulation under the skeeling on the inside of the room, so you lose a bit of the ceiling height, and then plasterboard over it, or you can buy a plasterboard insulation laminate and fix that on. That's the simple way of doing it, on the inside. Yeah. With a well-insulated house, the main vulnerable point is where the first floor ceiling meets the wall, and it's very difficult to get insulation around that joint. So what you can do there is to make a skeeling. In fact, cut a triangular block of insulation, fit it on the inside, and that will give you that insulation at that bit of corner. So.
Is there anyone you can pay to come and have a look around your house and point out all the bits that can be improved?
Yeah, there's
You've got a very big house, and it will take a couple of hours, I think, or more to go around it.
Yeah, there's a guy on the stand next to Draughtbusters does EPC energy performance certificates. Yeah, he will also come in and just give you advice. So, and there are sort of a few consultants like that. If you can find someone who isn't allied to a particular company, an insulation company, you're more likely to get independent advice. But he's completely independent. So, yes.
Do you know anything about the insulation you can put on the roof, under the roof, rather than?
Yeah.
Not the foam.
Sorry?
Not the foam, I've heard that's bad.
Yeah, there are advantages and disadvantages. If you insulate on the slope of the roof, you've got to be careful not to trap moisture around the timbers, because that can cause timber rot. It's generally best to insulate at ceiling level, because you've got a shorter, smaller dimension, so there's less area that you've got to insulate. If you use the roof, or if you use the loft, you can insulate between the rafters, and then you can probably put no more than 2 inches of insulation under the rafters, and that will keep. There's a thing called dew point. As a dew point, as moisture goes through the structure, it will reach a point in the structure where the air temperature goes, where the air can no longer hold the amount of moisture in it. So it starts condensation. So you'll get moisture in your structure at that point. So what you've got to try and do is keep the dew point towards the outside of the structure as much as possible. If it's brick or something like that, it's not such a great problem. But where you've got timber involved, if you get a build-up of moisture in the timber, you get problems. So you've got to be very careful about that. So
It's better to do it on the flat.
it's better to do it on the flat. Yeah.
I've got some, but it's not thick enough.
Yeah,
Am I correct to be able to use the space up there, really?
yeah. Well, if you use a cheap fibre insulation to the top of the joists, and then you can either put timbers the other way to put insulation between again, or just do that in the middle of the loft space, so you can get up there and you can insulate easily. But then around the edge, just 450mm of fibre insulation. It's relatively cheap to do, and it will give you a huge return. And then on the middle bit, just put 200mm. Use a foam board insulation there, not polystyrene, but one of the polyurethane or polyisocyanate boards, and that gives you half the insulation again of the fibre. So you can put a smaller thickness there, but still keep that insulation level going. So. Anything else?
I've got another one.
Yeah, no, that's fine.
What do you make of cavity wall insulation?
What do I make of cavity wall insulation? Sorry? Yeah, sorry. What do I make of cavity wall insulation? Cavity wall insulation is generally good. There used to be problems with the injected foams because the foam wasn't as durable as it was made out to be. But if using some of the blown fibres or the polystyrene with a glue fitted, they are generally good. Those can be used in more or less any exposure situation in the country, so you shouldn't get a damp-proof problem with them. If you do get a damp problem with them, it's probably a fault in the structure somewhere rather than the insulation. So you need to make sure that the pointing on the walls is the bit between the bricks is sealed properly. Pebble dash, yeah. Cement pebble dash will crack, so you're likely to get moisture ingress at the cracks. It's sorry. Yeah. The best thing you can do with the cement pebble dash is take it off and have it re-rendered. If you're going to do that sort of work, what you can then do relatively cheaply is to externally insulate the house while you're doing it.
But the pebble dash seems to come off first.
Not pebble dash. You put a render, just plain render
Over the top.
over the top of the insulation. So another thing, you can get brick slips which can be stuck onto the insulation and then pointed up, so it makes it look like a brick house again. But that is more expensive. The cheapest way of doing it is to render it, but it'll get rid of your pebble dash for you.
So that would be rendered over the top.
Yeah.
It wouldn't pull it off.
If the pebble dash, if the render holding the pebble dash is well fixed to the walls, you could probably fit your insulation over the pebble dash and then render over that. But you need to be putting 4 or 5 inches of insulation on it. The cost of additional insulation is very low compared with the actual labour costs of doing the work. So push for as much insulation as you can get if you're going to do something. But unfortunately, it's going to be expensive. So.
We've got only time for one more question, if that's okay.
Sorry?
One more question, if that's okay.
Yep, one more question. Yep.
I'm really enjoying your information that you've shared so far, and I just wanted to know if you've got cavity foaming, how long will that last? Like, how long?
Yeah.
Because I think you mentioned that the cavity foam, sometimes they weren't as good as is it fibre foam? Or was
Fibres and polystyrene bead. The ladies asked if you've got cavity foam, how long will it last? It depends on the installer, the quality of the foam. Goodness knows. You can check how well it's performing with an infrared camera. Heat have got one. West Berkshire Council have got two apparently, which they're not using. So give West Berkshire Council a nudge and get them to get their officers trained on it. I've already had a conversation with the guy in charge of their environmental department today. So keep nudging West Berkshire Council, get their cameras in use. They take a picture of the structure on a cold day, and it'll show up any heat loss in the wall. So you can get an idea of what's happening there. If you're fitting external insulation to a wall, you need to have the cavities filled. If they're not filled completely, it's not a problem, as long as there's a seal at the top to stop most of the air getting out the cavity. So the answer to failed cavity foam is either very expensively take it out, which involves cutting holes in the bricks, poking it out and then vacuuming it out, or to just assume, accept that you're not getting the benefit of that cavity insulation and just put external insulation on the wall. So, but as long as the cavity is sealed, the external insulation will give you a...